Yes, children, in last class we have discussed effect of temperature on resistance and resistivity. So today we will continue with combination of resistors. Resistors can be either connected in series or in parallel. Now 2 or 3 resistors are said to be connected in series. Suppose this is R1, this is R2, and this one is R3. These 3 resistors are said to be connected in series if they are connected end to end. One end of resistor R1 is connected to one end of resistor R2. Similarly, remaining end is connected to one end of resistor R3. End-to-end connection is termed as resistors in series. So resistors are said to be connected in series if they are connected end-to-end. And you also know that according to Ohm's law, the current flowing through any conductor is directly proportional to potential difference applied across the two ends of the conductor. Yes, when we come across two ends, there will be potential drop across this resistor. So the potential drop across R1 is V1. Similarly, across these two ends, once again due to the resistance offered by resistor R2, the potential drop will be V2. In the same way, potential drop across R3 is V3, battery potential is V. This is lucky. What is the concept? Combination of resistors. Under that, the first one is resistors in series. 2 or 3 resistors are said to be connected in series if they are connected end to end. Across each resistor, potential drop is different. Depending upon the value of resistance, for resistance R1 value, let the potential drop be V1, and across R2, potential drop is V2. Similarly, across R3, the potential drop is V3. Now it means that total battery potential, external battery, whatever we have connected in series to this combination, this total battery potential is equal to sum of potential drops across each resistor. That is V1 plus V2 plus V3. Now as you know that current flows from higher potential difference to lower potential difference. This is the conventional direction of flow of current. Yes? What is the conventional direction of flow of current? Current always flows conventionally from higher potential difference to lower potential difference. So net potential is sum of potential drops across each resistor. So let us call this as equation 1. Now it is clear from the circuit diagram that when resistors are connected end to end, we mean in series, since the direction, that is, since the path is same, hence same current flows through R1, R2 and R3. So another important point for resistors connected in series is same current flows through all the resistors. What is the reason? The path for current flow is same. Resistors are said to be connected in series if they are connected end to end. Across each resistor, respective potential drop occurs. So net potential is sum of potential drops across individual resistors. And in series, another interesting point is same current flows. Right now, from Ohm's law, what is Ohm's law? V is equal to I into R. Okay, now let us write V1. V1 is nothing but current is same, I across resistor R1. Similarly, potential drop across the second resistor R2, that is V2 is equal to I into R2. And V3, yes, I into R3. Let us term it as equation 2. Now this is our first equation and this is equation 2. Now you got, we need to substitute equation 2 in equation 1. Right? So substitute equation 2 in equation 1. Therefore, net potential drop V is V1. Now what is V1? V1 is I R1. Yes. What is V2? V2 is IR2 plus V3. V3 is I R3. I think you followed that why we are writing same I. Because when resistors are connected in series, same current flows. So take I common, then you are remaining with I R1 plus R2 plus R3 inside the bracket. Okay, this is resistors, combination of resistors in series. Now let us draw equivalent circuit of it. Now what is equivalent circuit? It is the single resistor connected in series to battery potential of V volt in series with a plug key, single resistor RS which plays the same role as 3 different resistors connected in series. So we term it as equivalent resistance. What is RS? Yes, equivalent resistance. Total current, same current is flowing, that is I. This is higher potential difference, lower potential difference. Okay, if we term it as equation 3, in equation 3, V can be written as V is equal to IR, once again from Ohm's law we know. Now we should write V is equal to I into, from equivalent circuit, I into RS. Therefore, equation 3 becomes. So left hand side, let us replace it with I into RS is equal to I into R1 plus R2 plus R3. Yes, we should cancel this. Finally, RS is equal to R1 plus R2 plus R3. Now you should write conclusion. What is the conclusion? Let us write in words. Equivalent series resistance is equal to sum of individual resistances when resistors are connected in series. Let me repeat it once again. Equivalent series resistance is equal to sum of individual resistances when 3 resistors are connected in series. Is that clear, children? Okay, let me dictate the first paragraph of this concept. Draw the circuit diagram. Start writing. consider 3 resistors R1, R2 and R3 are connected in series. I repeat, consider 3 resistors R1, R2 and R3 connected in series across a battery potential of V volt and a plug key. Change the para and write, resistors are said to be connected in series if they are connected end to end. And since path for flow of current is same, hence through all the resistors, current flow is same. That is, same current flows through R1, R2 and R3. We know that from Ohm's law, across each resistor, potential drops. Therefore, potential drop across R1 is V1, PD across R2 is V2. Similarly, PD across R3 is V3. Therefore, now you should write this equation, children. V is equal to V1 plus V2 plus V3. Name it as equation 1. Now you have written this, you need not write. Continue from here. Continue and complete. Now once you complete everything up till here, write the conclusion. Equivalent series resistance is equal to sum of individual resistances when 2 or 3 resistors are connected in series. Yes, children, this is many times repeated question. Your question will go like this. Derive expression for equivalent series resistance. The thing what you do is, you start with your circuit diagram, little bit explaining the circuit diagram, then derivation, then you should write conclusion. Now I have a note point over here, children. Note. This definition can be asked. Define equivalent resistance. Define equivalent resistance. Equivalent resistance is the single resistance. Equivalent resistance is the single resistance value which plays the same role as three resistors connected in series. Which plays the same role as 3 resistors connected in series. So that is how we have defined equivalent resistance. We mean we have defined RS. Okay, children, that is regarding the first combination, resistors in series. And remember, main circuit diagram, also you are going to draw equivalent circuit diagram, and compulsory you are going to write the conclusion. Yes, let us now proceed with the next derivation, next 5 marks derivation, resistors connected in parallel. Just now we have seen if resistors are connected side by side, I mean end to end, they are termed as resistors as if they are connected in series. Now 2 or 3 resistors are said to be connected in parallel. Let us call it as the first resistor of resistance R1. Let this be the second resistor of resistance R2. And let this be the third resistor of resistance, yes, R3. Now to this combination, across it, let us connect a battery potential of V volt. This is plug key. Okay, children, from higher potential difference to lower potential difference, as you all know, conventional current flows. Let us indicate it as I. The same current, I, flows out of the combination. Now, as soon as this point, okay, if we name it as A, B, or XY something, at this point, there is branch. That is, current should branch. When main current is I, along this path or through resistor R1, current I1 should flow. Through this second resistor of resistance R2, current I2 flows. Yes, very good. Through the third resistor of resistance R3, current I3 will flow. Two or three resistors are said to be connected in parallel if they are connected to common terminal. Check here, children. A, to all the 3 resistors, the terminal is A, one end is A, and the remaining end of the 3 resistors is B. So, to this common terminal of all the 3 resistors, across which a battery and a plug key are connected. Hence, resistors are said to be connected in parallel if they are connected to common terminal. And it is clear at this point current is branching. Current divider circuit we can call. When resistors were in series, we can now term it as potential difference divider circuit. Now resistors are in parallel. Main current is nothing but sum of individual currents across each resistor. Now let us term it as equation 1. Now go back to our Ohm's law, which states that across 2 terminals, a battery potential should be connected. Now since terminals are common, V is same. When resistors are connected in parallel, what is same? V is same. Now just go back. When resistors were in series, what was same? Yes, I is same. Now here V is same. So children, from Ohm's law, excuse me, we know V is equal to IR. V need I is V by R. Let us write each current. I1 is nothing but V is same, V by R1. Similarly, current through the second resistor, I2 is nothing but V upon R2 and I3 is nothing but V upon R3. Now, the entire equation, you term it as equation 2. Do you get this? Branch current across each resistor. Yes. You got the idea that now we need to substitute equation 2 in equation 1. So substitute equation 2 in equation 1. So LHS total current is nothing but I1. Instead of I1, very good, we should write V upon R1 plus V upon R2 plus V upon R3. Let us take V common on right hand side. 1 by R1 plus 1 by R2 plus 1 by R3. Let us term it as equation 3. Now let us draw equivalent circuit. What is equivalent circuit? All the three resistors connected to common terminal. Yes, we mean that. All the three resistors which are connected in parallel, it is replaced by single resistor which has the same effect. Which has the same effect as three resistors in parallel. Now same, across which a battery potential of V volt and plug key K are connected. Current is I. Now what is this? This is equivalent circuit. So from equivalent circuit diagram, let us write what is I. Similarly, from this equation, Ohm's law, I is nothing but V upon equivalent resistor is Rp, whose value is, resistance value is Rp. Okay, substitute in equation 3. Okay, so LHS you are going to put V upon Rp is nothing but V into 1 by R1 plus 1 by R2 plus 1 by R3. Now cancel this. So we are remaining with 1 by Rp is nothing but 1 by R1 plus 1 by R2 plus 1 by R3. Yes. If you are stopping till here, you are with 4 marks. Another 1 mark. For another 1 mark, you are going to write conclusion. Isn't it? What is the conclusion? In words, you are going to write this equation. The reciprocal of equivalent parallel resistance. I repeat, the reciprocal of equivalent parallel resistance is equal to sum of reciprocals of individual resistances when resistors are connected in parallel. That is the conclusion what you should write, children. So let us check what is the write-up work, what are the 3-4 lines you are going to explain regarding the diagram. First you need to draw a circuit diagram. Beside it, draw the equivalent circuit and start writing. Consider 3 resistors R1, R2 and R3 are connected in parallel across a battery potential of V volt and a plug key. Change the line and write. Resistors are said to be connected in parallel. Resistors are said to be connected in parallel if they are connected to common terminal. If they are connected to common terminal. Comma, it means V is same. When resistors are connected in parallel, what is same? V is same. Next. At point A, total current I branches out. I repeat, at point A, total current I branches out as I1 across R1, I2 across R2, and I3 along R3. Therefore, in the line and write, I is equal to I1 plus I2 plus I3. Call it as equation 1. Now continue from here. From Ohm's law, write everything as it is. All this you mention as equation 2. Continue and complete. Okay, children, now write down the conclusion. If you have completed till here, write down the conclusion. The reciprocal of equivalent parallel resistance, I am repeating, the reciprocal of equivalent parallel resistance is equal to sum of reciprocals of individual resistances, sum of reciprocals of individual resistances when 2 or 3 resistors are connected in parallel. When 2 or 3 resistors are connected in parallel. The last note point, define equivalent parallel resistance. Define equivalent parallel resistance. Equivalent parallel resistance, RP, has the same effect as the 3 resistors connected in parallel. Let me repeat. Equivalent parallel resistance RP has the same effect as 3 resistors connected in parallel. Okay, children, this question will be like this. Derive expression for equivalent parallel resistance. Many times it is asked like this. Derive expression for equivalent parallel resistance when 2 resistors are connected in parallel. So we have generalized it for 3 resistors. If only 2 resistors is asked, draw only 2 resistors. Everything is same. This extra term will go. This will not be there. This will not be there, right? And this is generalized concept, NCRT. Andre 3 resistors now parallel nalli connect madibittu derivation ಮಾಡಿವಿ. But exam ಗೆ 2 resistors ಅಂತ ಕೇಳಿದ್ರೇನು 3 ಬದಲು 2 connect ಮಾಡಿದ್ರೆ ಸಾಕು. Is this clear? So up till now we have dealt with combination of resistors, under which we have discussed 2 combinations. One is resistors in series. The second one is resistors in parallel. When resistors are connected in series, quick revision we are having. When resistors are connected in series, they are said to be connected in end-to-end form. Current is same. V divides. So only remember equation 1 for resistors in series. V is V1 plus V2 plus V3. What is same? I is same for series. Okay, now in case of resistors in parallel, right? Common terminal, what is same? V is same, very good. V is same. Then it is a current divider circuit. I is I1 plus I2 plus I3. So in this way, compare and remember. So practice so that you attain perfection. So just now we have derived R series, equivalent series resistance is sum of individual resistances when resistors are connected in series, end to end. Now, this is not point. For identical, n identical resistors, resistance value is not different if resistance value is same. All resistors are of same resistance R. Then R series will be R plus R and so on. Yes, n times R. Nth resistor, inond R. Totally finally we can write it as R series is nothing but n R. 1 plus R. Inond nth R antandre n resistors avalla. So we can write it as R series is n into R for n identical resistors connected in series. Further classes we will use this formula while solving the numericals. Similarly, for n identical resistors connected in parallel, means general formula we all know, 1 by Rp is nothing but 1 by R1 plus 1 by R2 plus so on plus 1 by Rn. If all resistors are identical, resistors of identical resistance value are 1 by R plus so on, was the last 1 by R nth values. So finally 1 by Rp is nothing but n, so many resistors are there. We can write n by R. If you reciprocate it, we want Rp. Rp is nothing but R upon n. Equivalent parallel series resistance is obtained by multiplying the number of resistors, n times R. Equivalent parallel resistance is obtained by dividing the number of resistors, that is R divided by n. For example, if we have two resistors of value, same value, R1 and R2 both are of same value, if we call it as, if we refer it as 2 ohm, then how can you write? R parallel is nothing but, what is the value of R? 2 ohm. How many resistors are there? I told 2 resistors. What is n? N is 2. So what is equivalent parallel resistance? 1 ohm, where ohm is SI unit of resistance which we have defined. Okay. Now if we are having two different resistors, R1 is 2 ohm and say R2 is 3 ohm. Now what is 1 by Rp? Yes, 1 by R1 plus 1 by R2, enough. Yes children, this can also be written as Rp is nothing but, if you take LCM and reciprocate, R1 R2 divided by R1 plus R2. I am telling you this example just that you should know this formula. In case of two resistors connected in parallel, this is equivalent parallel resistance. R1 R2 divided by R1 plus R2. Now from our example, now substitute whatever values are given. 2 into 3 divided by 2 plus 3, that is 6 upon 5 ohm. This is equivalent parallel resistance. Okay, this is what we require to solve numericals, and in further classes as a CT note, for n identical series resistors, equivalent resistance is n times R. For n identical parallel resistors, equivalent resistance is R upon n. Remember this formula. Now this also comes under note. This derivation will not be asked for you in the exam. We will have a small derivation on branch current concept. That is, we are going to have expression for branch current. Yes, all this concept you are going to write under note itself, children. This derivation will not be asked. Now let us suppose two resistors are connected to common terminal like this. What does it mean? They are connected in parallel. Yes, two resistors R1 and R2 are connected to common terminal. If we call this terminal as X, let us connect the remaining terminals of R1 and R2 to Y. So this is common terminal connection. The same story, across which a battery potential of V or EMF E. Right? So EMF, electromotive force, its definition and related concept of internal resistance we will discuss in tomorrow's class. Let us refer ಎಲ್ಲಿ ಸೆಲ್ ಬರ್ತದ ಹೈಸ್ಕೂಲ್ ಕಾನ್ಸೆಪ್ಟ್ ಓದಿರಿ ನೀವು, ಎಲ್ಲಿ ಒಂದು ಸೆಲ್ ಇರ್ತದ ಅಲ್ಲಿ ಅದಕ್ಕೆ ಎಲೆಕ್ಟ್ರೋಮೋಟಿವ್ ಫೋರ್ಸ್ ಇ ಎಮ್ ಎಫ್ ಇರ್ತದ ಮತ್ತು ಅದ್ರದ್ದು ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅದ್ರ ಹತ್ರ ಇರ್ತದೆ. ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂದರೆ ಮತ್ತು ಅಪೋಸಿಷನ್ ಟು ದ ಫ್ಲೋ ಆಫ್ ಕರೆಂಟ್ ವಿಚ್ ಇಟ್ ಆಫರ್ಸ್ ಇಂಟರ್ನಲಿ. ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಆಫ್ ದ ಸೆಲ್ ಆಲ್ಸೋ ಆಫರ್ ಅಪೋಸಿಷನ್ ಟು ದ ಫ್ಲೋ ಆಫ್ ಕರೆಂಟ್, ದಟ್ ಈಸ್ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಇದು ಇ ಎಮ್ ಎಫ್ ಆಫ್ ದಿ ಸೆಲ್. ಇ ಎಮ್ ಎಫ್ ಅಂತ ಹೇಳಿ ಬಿಟ್ಟಿಲ್ಲ ನೋಡ್ರಿ, ಇ ಎಮ್ ಎಫ್ ಆಫ್ ದಿ ಸೆಲ್ ಹತ್ರನೇ ಇರ್ತದೆ. ಸೊ ಅದಷ್ಟೇ ತಿಳ್ಕೊರಿ, ಎಲ್ಲಿ ಸೆಲ್ ಅದ, ಭಾಳಷ್ಟು ಸೆಲ್ ಇದ್ದರೆ ಬ್ಯಾಟ್ರಿ ಅಂತೀವಿ, ಅದೆಲ್ಲ ನಿಮಗೆ ಗೊತ್ತದ. ಒಂದೇ ಸೆಲ್ ಕನೆಕ್ಟ್ ಮಾಡಿ ಅದ್ರದ್ದು ಇ ಎಮ್ ಎಫ್ ಇ ಅನ್ರಿ, ಇಲ್ಲಿ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ನೆಗ್ಲಿಜಿಬಲ್, ನಾವು ಅದು ಏನೂ ಬರ್ದಿಲ್ಲ. ಇನ್ ಸೀರೀಸ್ ಪ್ಲಕ್ಕಿ ಕೆ ಅಂತನ್ರಿ. ನೋಡ್ರಿ ಇದು ಏನು ಒಂದು ಸೆಲ್ ಅದ, ಓಕೆ ಬ್ಯಾಟ್ರಿ ಅಂತ ಕರ್ದೀವಿ ನಾವು, ಭಾಳ ಸೆಲ್ಸ್ ಇದ್ದರೆ ಅದು ಕರೆಂಟ್ ಡ್ರೈವ್ ಮಾಡೋದು ಐ. ಇಲ್ಲಿ ಬಂದ ತಕ್ಷಣ ಬ್ರ್ಯಾಂಚ್ ಆಯಿತು, ಸೊ ಕರೆಂಟ್ ಡಿವೈಡ್ ಆಗಬೇಕು. ಅಕ್ರಾಸ್ R1 ಕರೆಂಟ್ I1 ವಿಲ್ ಫ್ಲೋ and across R2 current I2 respectively should flow. ಅಂದರೆ ಏನರ್ಥ, ವಾಪಸ್ ಇದು I1 ಇಲ್ಲಿ ತನ I2 ಇಲ್ಲಿ ತನ ಬಂದ ತಕ್ಷಣ ಹೊರಗಡೆ ಮತ್ತೆ ಮೇನ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗಬೇಕು. ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ನಲ್ಲಿ ಕರೆಂಟ್ ಸೇಮ್ ಅದ, ಏನು ಬ್ಯಾಟ್ರಿ ಕರೆಂಟನ್ನ ಡ್ರೈವ್ ಮಾಡ್ಲಿಕ್ಕತ್ತದ ಆ ಕರೆಂಟ್ ಸೇಮ್ ಅದ. ಸೊ ಸಿಂಪಲ್ ಕಾನ್ಸೆಪ್ಟ್ ಅದ, ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಯದ. ಟೋಟಲ್ ಕರೆಂಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಸಮ್ ಆಫ್ ಬ್ರಾಂಚ್ ಕರೆಂಟ್ಸ್. ಎಲ್ಲಿ ಟರ್ಮಿನಲ್ ಕಾಮನ್ ಅದ ಎರಡು ರೆಸಿಸ್ಟರ್ಸಿಗೆ ಅಲ್ಲಿ ಕರೆಂಟ್ ಡಿವೈಡ್ ಆಗಬೇಕು. ವಾಟರ್ದು ಪೈಪ್ ಒಂದೇ ಅದ, ಆ ಪೈಪಿಗೆ ಮತ್ತೆ ಎರಡು ಪೈಪ್ಸ್ ಮತ್ತೆ ಅಲ್ಲಿ ಸ್ಪ್ಲಿಟ್ ಆಗ್ಯಾವ, ಡಿವೈಡ್ ಆಗ್ಯಾವ ಅಂತಂದರೆ ಎರಡು ಪೈಪ್ಸ್ ನಿಂತ ಮತ್ತೆ ವಾಟರ್ ಹೆಂಗೆ ಡಿವೈಡ್ ಆಗ್ಲಿಕ್ಕತ್ತದ ಎರಡು ಪೈಪ್ಸ್ ನಿಂತ, ಸೇಮ್ ವೇ ಮೇನ್ ಕರೆಂಟ್ ಎರಡು ರೆಸಿಸ್ಟರ್ಸ್ ನಿಂತ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆ ಥರ ಅದು ಡಿವೈಡ್ ಆಗಬೇಕು. ಅಂದರೆ ಮ್ಯಾಥಮೆಟಿಕಲಿ ಐ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ I1 + I2 ಅಂತ ಬರ್ಕೋಬಹುದು. Okay, now this combination will behave as effective parallel resistance. ಇದು ಅಷ್ಟು ಸೇರಿಬಿಟ್ರೆ ಆರ್ ಪಿ ಕೆಲಸ ಮಾಡ್ತದೆ ಅಂತ ಗೊತ್ತದ ನಮಗೆ, ಈಕ್ವಿವ್ಯಾಲೆಂಟ್ ಪ್ಯಾರಲಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂತ ಅಂದ್ಕೊಂಡ್ರೆ. ಸೊ ಫ್ರಮ್ ಓಮ್ಸ್ ಲಾ V is equal to IR. V ಬದಲು ನಾವೇನು ಬರ್ತೀವಿ, ಇ ಎಮ್ ಎಫ್ ಬರ್ತೀವಿ. E is equal to I. ಆರ್ ಬದಲು ಈಕ್ವಿವ್ಯಾಲೆಂಟ್ ಎಲ್ಲ ಸೇರಿಬಿಟ್ಟು ಏನು ಅನ್ಸ್ಕೊತದ, ಆರ್ ಪಿ ಐ ಆರ್ ಪಿ. ಓಕೆ, ಹೀಗೆ ನಾವು ನೋಡೀವಿ ಆರ್ ಪಿ ಎರಡು ರೆಸಿಸ್ಟರ್ಸ್ ಪ್ಯಾರಲಲ್ ಇದ್ದಾಗ ಆರ್ ಪಿ ಅಂದರೆ R1 R2 ಡಿವೈಡೆಡ್ ಬೈ R1 + R2. ಸೊ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಆರ್ ಪಿ, ಸಿನ್ಸ್ ವಿ ನೋ ದ್ಯಾಟ್ ಆರ್ ಪಿ is equal to R1 R2 ಡಿವೈಡೆಡ್ ಬೈ R1 + R2 ಅನ್ನೋದು ಈ ಈಕ್ವೇಷನ್ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿರಿ. ದೇರ್ ಫೋರ್ ಇ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಐ ಅದು ಹಾಗೆ ಇಟ್ಕೊಂಡು ಆರ್ ಪಿ ಬದಲು ಯು ಗೋಯಿಂಗ್ ಟು ರೈಟ್ R1 R2 ಡಿವೈಡೆಡ್ ಬೈ R1 + R2. ಗಿವ್ ಸಮ್ ನೇಮ್ ಟು ದಿಸ್ ಈಕ್ವೇಷನ್, ಈಕ್ವೇಷನ್ 2 ಅಂತ ಕರೀರಿ. The branch current through first resistor R1 is I1, branch current through second resistor R2 is I2. ಮತ್ತು ಓಮ್ಸ್ ಲಾ ನಿಂತ ಈಗ ಅದು ಬ್ರಾಂಚ್ ಕರೆಂಟ್ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ I1 ಈಸ್ ನಥಿಂಗ್ ಬಟ್ E ಡಿವೈಡೆಡ್ ಬೈ ಫಸ್ಟ್ ರೆಸಿಸ್ಟರ್ ಅಲ್ಲ. ನೋಡ್ರಿ ಇಲ್ಲಿ ಇದಿಷ್ಟೇ, ಈ ಒಂದೇ ರೆಸಿಸ್ಟರ್ಗೆ ನೀವು ಓಮ್ಸ್ ಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕಾದ್ರೆ ಈ ಸೇಮ್ ಅದ. E is equal to I1 R1 ಅಂದರೆ I1 ಹೆಂಗೆ ಬರಿಬೋದು ನಾವು, E ಡಿವೈಡೆಡ್ ಬೈ R1. ಸೊ 1/R1 ಅದೇ ಥರ ಇಟ್ಕೊಂಡು ಏನು ಮಾಡ್ಲಿಕ್ಕತ್ತೀವಿ ಹೇಳ್ರಿ, ವೆರಿ ಗುಡ್. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಈಕ್ವೇಷನ್ 2. ಸೊ 1/R1 ಅದೇ ಥರ ಇಟ್ಕೊಂಡು ಈ ಬದಲು I ಇಂಟು R1R2 ಡಿವೈಡೆಡ್ ಬೈ R1 ಪ್ಲಸ್ R2 ಏನು ಮಾಡಿವಿ ನೋಡ್ರಿ, ಇನ್ನೊಮ್ಮೆ ನೋಡ್ರಿ, ನಮಗೆ ಬ್ರಾಂಚ್ ಕರೆಂಟ್ I1 ಬೇಕಾಗ್ಯದ. ಮತ್ತು ಅದೇ ಸಿಂಪಲ್ ಓಮ್ಸ್ ಲಾ ಅಪ್ಲೈ ಮಾಡೀವಿ. E is nothing but I1 R1. I1 ಬೇಕಲ್ಲ, ಸೊ I1 is nothing but E upon R1. ಈ ಬದಲು ಇದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೇಕಂತ ನಿಮಗೆ ತಿಳಿದದೆ, ಯಾಕಂದ್ರೆ ಮೇಲೆ ಈಕ್ವೇಷನ್ 2 ಅದ. ಸೊ 1/R1 ಹಾಗೆ ಇಟ್ಕೊಂಡ್ಬಿಟ್ಟು ಅಲ್ಲಿ I ಅದ ನೋಡ್ರಿ, I ಬಾರ್ದು, ಇದಿಷ್ಟು E ಅದ, ಈ ಜಾಗಕ್ಕೆ ಹಚ್ಚಿಬಿಟ್ರಿ. ನಾವು ಕ್ಯಾನ್ಸಲ್ ದಿಸ್. ಫೈನಲಿ I1 is nothing but I R2 divided by R1 plus R2. ಇದು ನಿಮಗೆ ಫಾರ್ಮುಲಾ. ಸೇಮ್ ಇಫ್ ವಿ ಪ್ರೂವ್ ಫಾರ್ another current, that is another branch current I2 is nothing but, proof ಬೇಡ, ಆ್ಯಕ್ಚುಲಿ ಇದು ಡೆರಿವೇಷನ್ ಬೇಕಾಗಿಲ್ಲ ಅಂತ ಹೇಳಿ ನಾನು. ಸೊ ಕನ್ಕ್ಲೂಷನ್ ಡೈರೆಕ್ಟ್ಲಿ ಕೊಡೋಣ. ಸಿಮಿಲರ್ಲಿ ಬ್ರಾಂಚ್, ದ ಸೆಕೆಂಡ್ ಬ್ರಾಂಚ್ ಕರೆಂಟ್ I2 is nothing but I R1 divided by R1 plus R2. ಈಗ ಯಾವುದು ಫಾರ್ಮುಲಾ ನೀವು ನೆನ್ಪಿಟ್ಕೋಬೇಕಾಗಿಲ್ಲ, ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ದ ಫಾರ್ಮುಲಾ ಇನ್ ವರ್ಡ್ಸ್. ಎನಿ ಬ್ರಾಂಚ್ ಕರೆಂಟ್ yes children, it is equal to, what is I? I is main current in the circuit, main current into what is R1. See, when we want branch current I2, then R1 is resistance of other branch. Now we are interested in I2 branch current. Branch current is main current into resistance of other branch. When we want this branch current, what is the resistance of other branch? Other branch is R1. Yes, main current into resistance of other branch divided by, what is R1 plus R2 inwards? Sum of resistances. Sum of resistances. Check once again. Yes. Now let us see this formula. What is I1? Branch current through resistor R1. I1 is branch current through resistor R1. So this branch current once again is equal to main current. I is main current. We want I1. What is resistance of other branch? I1 illada. Innondu branch in resistance estada? R2. Yes. So main current into resistance of other branch upon sum of resistances. So this is a small note. You need to remember these two formulas. ಅದು ಫಾರ್ಮುಲಾ ನಾ ಹೇಳಿನಲ್ಲ, ನೆನ್ಪಿಟ್ಕೊಂಡಿಲ್ಲ ಅಂದ್ರೇನು, ಮೇನ್ ವರ್ಡ್ಸ್ನಲ್ಲಿ ನೀವು ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಮಾಡೋ ಹೊತ್ತಿಗೆ ಈಸಿ ಆಗ್ತದೆ. ಓಕೆ, ಸೊ ಇದಕ್ಕೇನು ಥಿಯರಿ ಬರಿಬೇಕಾಗಿಲ್ಲ, ಡೈರೆಕ್ಟ್ಲಿ ನೀವು ನೋಟ್ ಅಂತ ಬರ್ಕೊಂಡು ಬಿಡ್ರಿ, ಆಸ್ ಇಟ್ ಈಸ್ ವಾಟ್ ಎವರ್ ಇಸ್ ಆನ್ ದ ಬೋರ್ಡ್. After this children, we are going to continue with some interesting numericals on combination of resistors, and see that you are practicing your day-to-day classes. Don't get discouraged. If you are perfect with class 1, then the topic is more interesting. Thank you.